for coming tonight. I'm actually surprised to see this many of you all, so thank you all. I appreciate doing that. And about half are my students, but I did not bribe them as far as you know. So this is really cool to do this because Joan Crawford, I came here and overlapped with Joan for a good number of years. I think I'm the longest lasting faculty person at this point. Jack DeBose, who's a faculty member now, was here before me, but Jack initially started on staff. So, but I overlapped with Joan, and she was great. She was so supportive. Her husband, Bill, was such a good guy. I did stuff with, I think, some things that her granddaughter was involved with way back when we did some things on Saturdays here. So she was terrific, and it's an honor to be able to participate in this. But if I am honest with you, I feel a little bit like this guy. Now, do any of you all know who this is? This is Jay Ferguson. By the way, I just want you to notice, see if that light works. Awesome shoes, by the way, right? So Jay Ferguson was a one-hit wonder from later in the 70s, okay? And he did a song that perhaps you know called, anybody know? Thunder Island. Okay, right? Do-do-do-do, do-do-do, 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 do-do, da-da, do-do-do-do, do-do-do, 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 do-do. Yeah, that one, okay? So, picture this. It's 1979, Royal Stadium in Kansas City, and I am at a summer jam, okay? Featuring the Pat Travers Band. Famous song, Boom Boom, Out Go the Lights. That's probably the only one some of us have heard. Little River Band, Santana, and the headliners, REO Speedwagon, who played Riding the Storm Out. They came back on the stage after leaving it in the middle of, honest to goodness, there was a tornado warning. And they came back out and played Riding the Storm Out, and we thought it was awesome. So anyhow, but you know who the opening act was? Jay Ferguson. And this guy. And I feel like this guy because this series, this last fall, we've had a lot of great speakers. Dr. Ryan Herod, who's my boss, and so I have to say his was really good. Beth Luers, a legend here at Garrett College. Dr. Emily Hager, who I knew when she was months old. And then we've got a great lineup this spring. And compared to these heavy hitters, I feel like this guy. But just like him, I'm going to give my all playing the one hit that I know. So as I mentioned, I grew up in the Kansas City area. So I grew up right in there somewhere, okay? And I'd never seen a bog. But I liked birds. And every spring for several weeks, these little energetic, colorful sprites called warblers would come through, having left their wintering home in the tropics, many of them, and headed up north to a land of spruces and pines and bogs. And I got to see them for a few weeks at the most, but I always thought it would be so cool to go up to this area, right up there, where they lived in the summer, or so I thought. And but then something really cool happened. I ended up going to graduate school right there in the UP of Michigan at Michigan Tech, right? So here's Michigan, here's the really cool part of Michigan, and here's the coolest part up here, and that's where I went to school. And so as I drove, I met somebody in downstate Michigan, drove up through lower Michigan, and I started to see conifers, right? Spruces and pines, all these things I dreamed of. And further north, as I'm driving into the Keweenaw Peninsula on US 41, I look on the right side of the road, and there's this opening out there, and I went, a bog. And so I parked my vehicle. It was a really awesome yellow 1973 Datsun pickup with a camper shell. And I went down the slope, and I walked out into what I thought was like, you know, a field. Except it felt like walking on a wet, squishy waterbed. And as I walked, the trees and the shrubs around me were waving back and forth, and I thought, that was so cool. It's a bog. And so I fell in love with these northern habitats. And in fact, I got to do my research on Isle Royale Island in Lake Superior, did my research on warblers, and I got to wander around in a lot of bogs, and that's where I did my research. And so when it was time to move to my next stage of education, came down to WVU. And in preparation, I read up on the habitats and the birds of West Virginia, and it was really cool to discover that West Virginia, the Central Appalachians, was home to some of the same species that I knew from up north, right? You had spruce, and you had bogs, and you had cool places like Cranberry Glades and Dolly Sods and Canaan Valley and a place called Cranesville Swamp. And so when I got here to this region, I went and visited those places. And I was really excited about the prospect of doing my research, my research in high elevations. But instead, I ended up near Berkeley Springs, West Virginia, looking at the impact of gypsy moth on bird habitat, which was cool. But Berkeley Springs is hotter than a hoot owl, and they're like 5 bazillion gnats, you know, doing this right around your eyes. And it wasn't the same as this kind of place in my mind. But as I would drive from the steaming, you know, climb of Morgantown up and over the mountains on I-68 to drop back down to Berkeley Springs, as I went through this cool part of Maryland called Garrett County, I looked over in the vicinity of the Lower New Germany Road exit at this place. It's Wolf Swamp. And I said, that looks like a bog. And I thought how cool it would be to live up here in the mountains in Garrett County. And lo and behold, I got my job here at Garrett College. And so for the past 34 plus years, I have been privileged to work in these cool environments, these areas called mountain peatlands, working on northern saw-whet owl with my students, and working with the Maryland Department of Natural Resources, and working with the Nature Conservancy. And I've gotten to know some of these places better, in particular, one of my favorites, Cranesville Swamp. And so I will tell you, I've been to a lot of cool places in my life, Southeast Arizona, Alaska, so many other places. But I think my favorite places of all are these high elevation northern Appalachian wetlands that we call mountain peatlands. And you know what? I think mountain peatlands are cool. And I think you should too. So I want to tell you about them. So to understand mountain peatlands, we have to understand what that is, right? And the first thing we need to do is understand, well, what is a peatland? And to get that, it all starts with peat, okay? Now, peat is an organic soil, right? It's mostly living or formerly living matter. In fact, a peat is a soil composed of undecomposed plant matter. In fact, a peat soil is defined as having at least 2/3 of what's in it recognizable parts of plants, okay? And peat accumulates in wetlands, giving a certain unique set of conditions. So to understand how these happen, how we get peat, we need to first understand the challenges that plants face when they live in saturated or inundated soil. When you've got moisture, you got water to the surface of the soil or actually above it, okay? One of the things is there is little oxygen available, Now, why is that a problem? Because you know what the deal is, right? Okay? Plants take carbon dioxide in, right? Photosynthesis, and they breathe it out, and the animals go, oh, thank you so much for that oxygen. I need that oxygen. And then they go, and here's the carbon dioxide. And the plants go, oh, thank you so much for that carbon dioxide. Makes me so happy. Here, animals, there's some oxygen. The animals go, oh, thank you so much. That's very nice of you. Here's some carbon dioxide back. And it's a happy little circle of life, and the world is like a rainbow, right? Because plants need carbon dioxide for photosynthesis, right? Animals need oxygen for breathing, right? And why do they need to breathe? To live. And why do they need to live? So you see, the problem is, why do you need oxygen? You need it because you need it to most efficiently break down your food and extract the most energy possible for your cells to do work. It's called aerobic cellular respiration. Well, let me ask you a question. Do you suppose that plants need to do that? They make food, right? But what do they do with it? They got to use it to do stuff too, right? To maintain themselves, to grow, to reproduce, right? Plants need oxygen as well. But in the roots and the lower parts of the plants, when they're below the surface of the water and there's no oxygen available, it's a problem because they have to resort to a less efficient form of respiration, anaerobic cellular respiration. And when you use that, you get less energy for the same amount of food, and you release these toxic byproducts. And so that creates a less optimal condition for growth. So there's no oxygen or little oxygen. You accumulate these toxic gases. And the other thing is you get this abnormal concentration of different kinds of ions. So this graph shows what happens. Doggone it, he's going to do science, right? So the longer soil is inundated and oxygen is depleted, right? You go from high concentration to low very quickly. You lose nitrogen, which plants kind of need, right? But you begin to get an accumulation of things that are less favorable for growth, including iron, manganese, hydrogen sulfide, methane, okay? And so these conditions all pose problems for plant survival and growth, okay? Now, here's the other thing. Peatlands. This looks at different kinds of wetlands, and it organizes them by how deep they're flooded with water and for how long, right? And in peatlands, flooding is basically permanent. You have water to the surface all the time. So that means what? Not much oxygen, right? But the water is shallow. It's not above the surface like it is in a marsh or a pond or something like that, okay? So no oxygen, but you don't have wave action to move away organic matter, so it just sits there and accumulates, okay? And once organic matter accumulates more than 10 centimeters, about 4 inches, right? Now roots that plants at the top of that peat, they can't access mineral soil anymore. And it's the mineral soil that provides the nutrients that they need, because peat itself, we use it, right, for growing stuff, but we don't use it for its nutrients, right? And so peat, depends on the kind of peat, which we're going to talk about, is relatively infertile, okay? So this is an issue. Peatlands are challenging growing conditions for plants, right? Okay? So plants that grow in peatlands have developed some interesting adaptations. For one thing, they have this evergreen leathery foliage, okay? So they're trade-offs. If you retain leaves year-round, you're far more prone to desiccation, to drying out, because you've got your leaves sitting there in the winter. Same thing with pines, okay? But the advantage of having your leaves is you don't drop your leaves and then have to gain more nitrogen and phosphorus, which is in short supply, to generate new leaves the next year. So it's a particular type of strategy. So you see these in peatlands. To make up or to maximize uptake of nutrients, a lot of peatland plants have mycorrhizal fungal associations. So mycorrhizal fungi are these fungi that develop intimate interconnections with plant roots, gain food, let's say from the plants, but can provide them with water, can provide them with nutrients. And we are learning a whole bunch of really cool stuff about mycorrhizal fungi these days. If you've ever seen Finding the Mother Tree by Suzanne Simard, talks about a lot of this. There's a book called Entangled Life about fungi. Fascinating stuff, and we're just scratching the surface. So some of these peatland plants develop these relationships. And some peatland plants take supplements. What I mean by that is some plants will capture insects and other invertebrates, okay? Because the plants get their food from the roots, right? They get their energy from somebody, get their food, their nutrients from the roots. But if there's not much, if you can somehow capture animals and break them down and extract nitrogen and phosphorus from them, then you're ahead of the game. And so there are plants, and we find a lot of our carnivorous or insectivorous plants, bladderworts, pitcher plants, Venus's flytraps, sundews, etc. We find them in peatlands or similar environments because it's an adaptation for increasing your nutrient uptake. So when we get to peatlands, the dominant vegetation are bryophytes, especially mosses, okay? In fact, there is no other habitat on Earth that is so dominated by bryophytes as peatlands. And there are a variety of mosses that you can find depending on the conditions, but the most prominent group, the most prominent genus is this stuff, which is called sphagnum, peat moss, right? And in fact, there are at least 20 species of sphagnum that can be found in our mountain peatlands. It all looks the same to you, but you ever been out like on the boardwalk at Cranesville and some of them look reddish, right? And some look more green. If you've ever noticed that, there are a lot of species out there. They all look like moss, but they're different. And sphagnum is unique. It's built like a sponge. You have photosynthetic cells, but you have these large kind of empty cells called hyaline cells. And between those cells and all the little spaces between the leaves and stems of sphagnum, roughly 98% of a carpet of sphagnum is pore space, which allows it to soak up water. Which is, so if you've ever gone and you just pulled the surface layer of sphagnum, you can wring out water. It's pretty interesting. And sphagnum has a profound effect on its environment. It makes its environment permanently wet, so it holds water. It releases hydrogen ions, so it increases the acidity of its environment, which basically makes it even harder for competitors to grow. And it produces other organic compounds that can negatively impact the growth of plants. So peatlands are unique environments, but not all peatlands are created equal. And if you've ever studied this stuff or learned about that, there's a lot of confusing terminology regarding peatlands. So for instance, some people call a peatland a mire, or you may have heard of bog and fen. And what you call a peatland tends to depend on where you are, who taught you, etc. Okay? So really, it's not bog or peat. There's a gradient, at least one way of looking at this, from fens to bogs. So fens, bogs are acidic, right? Their pH is distinctly below 7, which is neutral. And fens are circumneutral or slightly alkaline, okay? And so that affects decomposition. More acidic, less decomposition. Peat tends to accumulate faster and deeper. Whereas a fen, as you get higher in pH, decomposition is higher, you have less accumulation of peat. In our region, bog type environments tend to be underlain by sandstone. And we have a lot of sandstone here, right? And it tends to be more acidic, whereas areas that are fens tend to be underlain by limestone, calcium carbonate, which is more neutral to slightly alkaline, okay? The source of nutrients from water also varies. In a bog, your primary source of water and therefore nutrients comes from the atmosphere, so it's lower in available nutrients, whereas in a fen, it's mostly fed by groundwater, more nutrients, right, and more fertile, if you will. So therefore, bogs tend to have lower plant diversity, fens higher, and the vegetation differs. In fens, you have some mosses, you have a lot of grasses and other grass-like plants called sedges, whereas in bogs, it's sphagnum is dominant. You have sedges, you have heaths, and that's not a candy bar. A heath is a member of the blueberry family. So, right, rhododendron, blueberry, etc. Blueberries, huckleberries, cranberries, etc., which are specifically adapted to growing in lower pH soils. And you have a lot of conifers, okay? So now in our area, we have some of our peatlands are underlain by limestone, okay? And so you might call them a fen, or there are parts of some of our peatlands where limestone is higher, and so they're kind of fenny, but in general, most of our mountain peatlands are typically called bogs, unless you grew up in the north. And you say, those aren't bogs, because bogs are where you had glaciers, right? Bogs, because as glaciers receded, they left chunks of ice, depressions in the landscape, gradually filled in. That's a bog, and they say, those aren't bogs. So you can have this argument, you just say, whatever. Those are bog snobs, and we just don't listen to them, okay? Functionally and vegetatively, our peatlands are much the same as a classic northern bog, all right? And in a 1984 publication, George Fenwick and Dan Boone defined a peatland like this. It said it's a wetland that's characterized by lower pH water, right? Doesn't drain well. You've got sphagnum, a lot of that, and you have a variety of plant species that are typical of glaciated northern latitudes. And it's true. If you are a bog snob, when you walk around our peatlands, you're going to see a lot of the very same species. So that's what a peatland is. But I said we're talking about mountain peatlands, so the question is, where does the mountain come in? What do mountains have to do with our peatlands? To understand this, we need to think about geography. So here is the eastern U.S., a relief map of the eastern U.S. Here are the Appalachians, right? And here we are in the central Appalachians right in here. And as we blow this up to Maryland and nearby, we recognize, and you know this, if you come from downstate, from Ocean City, up here and all the way over to Morgantown, you see that the highest area of that drive is right in here from far western Allegheny County over to about the Monongalia County line, right? We are in this area of higher elevations. In fact, these are the highest elevations that you encounter at this latitude between the Atlantic Ocean and eastern Colorado. Think about that, okay? So, here we have, we lie within what's called the Allegheny Plateau or the Appalachian Plateau or the Allegheny Mountains with elevations consistently over 2,500 feet. And what is that? What's the consequence of that? Higher elevations, lower temperatures, right? And so what that means is it's colder. We have snowier winters. So mountain peatlands occur in areas with lower average annual temperature, longer, colder, and snowier winters, and shorter growing seasons. It's that shorter growing season that is really the key, okay? Right, So for us, growing tomatoes up here is more challenging, at least in the greater Binninger metropolitan area, than it is if you live down off the plateau to the east, right? Because we have a shorter growing season. And here is the thing, as you go up in elevation, it's like going further north in latitude. Think about if you have field guides, if you're interested in birds, for instance, or plants, and you look at range maps in your field guides, and you look at northern species like dark-eyed junco, right? So when do you think of seeing juncos? Do you know what a junco is? Snowbirds? Those dark birds with white bellies and white flash to the edges of their tails that bop around your bird feeder. They show up maybe in October, November, and they leave by the end of April or so, right? Those are juncos. We think of those as winter birds, but look at this range map. They're ranged tongue south through the higher elevations of the Appalachians, and you see that pattern repeated for a lot of northern species, plants and animals, okay? So being at a higher elevation, right, here in the Appalachians or out west, is like being further north, if that makes sense to you. But there are higher elevations of our region have another consequence, another influence on climate, and that is in terms of precipitation. As air masses, and this comes from Earl Core's book about the vegetation of West Virginia. My students may recognize this figure from the introductory part of the Flora of West Virginia. As air masses laden with moisture come from the west, they encounter the higher elevations of the Appalachians, and they're forced upward. And as they're forced upward, the temperature of that air mass cools. Colder air can hold less moisture than warmer air, so that moisture condenses, and you begin to get enhanced precipitation as you go up the western slopes and onto the top of the Appalachians. That influence lessens as you go east at the same elevation, and of course, you get far less precipitation on the east face of the Appalachians. So what you have, if you think about Allegheny County, you actually have cactus. You may not know this, but as you've driven I-68 in the vicinity of Flintstone, you are driving by prickly pear cactus, okay, which is cool. But up here, it's wet. So if we look at the precipitation map for Maryland, the highest levels of precipitation are in the western half of Garrett County, and it's fairly wet throughout and much drier to the east, okay? So what we have is, for the consequence is that our region is cooler, right? And it's wetter, and these are conditions, and so it's wetter and it's more northern, right, if you will, and those are conditions that would seem to be good for mountain peatlands, but the thing is, we don't find mountain peatlands just anywhere. They're not everywhere you go, right? Okay? These black areas are mountain peatlands in Garrett County. So they're not everywhere in Garrett County. They're not everywhere in nearby West Virginia, right? Canaan Valley, right? Cranberry glades and stuff down here, but they're not everywhere. They're not even everywhere nearby Pennsylvania. So there is something else going on because they're concentrated in certain areas. So what else is going on? It's local topography, lay of the land. Most of our mountain peatlands lie in narrow or bowl-shaped valleys at the heads of watersheds, where streams, waters come down, and it is eroded down through less resistant rock, such as shale and limestone. If you can picture going to Cranesville Swamp, if you go up over Piney Mountain or up over Snaggy Mountain, you descend to the swamp, right? And it's at the head of a watershed. And so what happens is the water spreads out over that flat valley, and that's often enhanced by more resistant rock that forms kind of a dam backing up water. Sometimes beaver dams have also helped create that situation. So you've got water ponding out, okay? In other situations, like at the glades or the peat bogs, so think about, you know where Peat Moss Road is off of Rock Lodge Road? If you go east of here on Mosser, all of a sudden you're up on top, right? You're on this high plateau between Negro and Meadow Mountains, right? And it's relatively level, but you get this bog up there, or this peatland. This is the lake where they mine the peat, and this is where it's still intact. And it's really not in a deep valley at all. It's sitting on top, but it's, and you see this also like up on Dolly Sods, it's sitting on very resistant hard rock, the Pottsville Formation, and so it spreads out laterally there. But either way, you've got these at least shallow depressions. So that's even wetter than the rest of the area in terms of water accumulation. But there's yet another consequence, because these shallow depressions form what we call frost pockets. Now, I don't know if you know what a frost pocket is, but if you go like to Shop and Spend down there and you get the, you go to the freezer section, you ever had those frost pockets? Oh my goodness, they're tasty, right? So that's, no, that's not what a frost pocket is. What a frost pocket is this. On calm, clear nights, like tonight, like last Friday night, Saturday morning, okay? As the sun sets, the heat that the earth absorbed radiates into the sky, and the air cools at the surface of the ground. And as air cools, it gets more dense, okay? And that air begins to settle in the low points in the landscape. And if it's cold enough, what happens? Frost. Think about in your yard, your neighborhood, the first places you see frost, right? It's not on top, it's in those depressions, okay? And so those are the last places to frost in the spring and the first places to frost in the fall. And so what that means is that those are the places with the shortest growing conditions. Here's an aerial of Cranesville Swamp. In the fall, the first place where leaves change color is not on the hillsides or on the tops of those surrounding hills and mountains. It's in that valley, right? So what you have is, to summarize, our mountain peatlands occur in an overall cooler and wetter region, right, where we are. But particularly in sheltered local depressions in the landscape that hold water and experience frosts later in the spring, early in the fall, hence have shorter growing seasons, right? And so, and then where water accumulates, it permits the buildup of peat. So the thing is, a place like Cranesville Swamp is not colder. Now, if you go out there on a raw, windy day in the winter, it feels colder, but it is not colder than the hillsides, okay? But on certain nights, it is, and that's what's important, is that shorter growing season. Because plants that are adapted to a shorter growing season can live there, but they get outcompeted in areas with a longer growing season with other species that need a longer growing season. So they can hang on in those lower places. But the question is, how did these northern plants ever get to these mountain peatlands? And the answer to that lies with the relatively recent Wisconsin glaciation. Now, we weren't, and this is what happens from about 25,000 to 11,000 years ago. We did not get glaciated here. If you've ever driven north from Pittsburgh, you eventually get on I-79, you get past Moraine State Park. That's the southern terminus of the Wisconsin Glacier, right? So we were south of the glacier, but we were very much influenced by the impact of this massive sheet of ice to our north. Cold winds blew south. And what happened as glaciers advanced is vegetation adapted to colder climates gradually moved southward. Everything got shoved south. You can find records of spruce pollen in certain places way down in the deep south. So things changed, right? And the way we know this, that we were in a paraglacial environment, is through pollen of plants that were preserved in various things, including a local bog. When you look at the literature for pollenology, study of fossil pollen, one of the famous places where this study is a place called Buckles Bog. And Buckles Bog is the glades, okay, the Buckle family. They spell buckle differently in some of the books, but it's Buckles Bog. Because you have, if you take a core and you go all the way down, 18,000 years into the past, through that bog, that pollen, and you pull it up, you can look at the pollen from the bottom up to the top, and you can retrace the history of vegetation in our area. So these next couple of slides were provided to me by Jim Wrench at WVU, okay? And we won't get into all the specifics, but I'm going to tell you what this is telling you, is that starting about, so the pollen at the bottom of these cores is pollen from grasses and sedges. Sedges are grass-like plants, and they indicate a cold grassland, a steppe, or almost a tundra environment. Starting about 14,000 years ago, reflecting the beginning of the recession of glaciers, right, melting on the southern terminus, so receding northward, we see a shift in the pollen to boreal forest species like spruce and pine and fir. Gradually, you see evidence of continued warming because you see a shift to birch and hemlock. Now, an interesting thing happens about 5,000 years ago. We entered a period where it was warmer than now, the post-glacial maximum, or the hypsothermal. And so you see that blip in there of even warmer temperatures. Then you see a resurgence of things like spruce and pine. And it's only in relatively recent years where you see things like oaks and stuff like that. So what that tells us is we had more northern vegetation here at one time, but as glaciers receded, all that vegetation gradually moved northward and upward in elevation. And in most cases, it left. But there were these certain special localities, these frost pocket environments, where these plants and animals hung on, right, because the conditions permitted it. The local growing season length permitted it, and that's where so we're seeing remnants of vegetation reflecting what happened many thousand years ago, okay? So that is what's going on. And so the plants that are dominant in much of our area, even though they're adapted to cooler conditions, they're not adapted to, whoops, there we go. They're not adapted to the current conditions, but you've got these certain places where plants that need shorter growing conditions can hang on and survive, okay? So that's what we mean by mountain peatland, all right? Now, we use the term mountain peatland, and very specifically it refers to open bogs dominated by sphagnum. But we tend to use mountain peatland for the whole complex of wetlands that we see in these sites. So again, this is this area of Cranesville Swamp. It doesn't all look the same, right? There are various different habitats and different ways of classifying that. For instance, if you look at the Nature Conservancy's site conservation plan for Cranesville Swamp, this is going to be on the test, okay? All these plant community types, okay? Upland forest types, conifer swamp forests, hardwood swamps, wet shrubland, bog, peatland, etc. And so you have all these different, I think that's it, different vegetation types. Now, what's not important for you is to know all those specifics, but to recognize that roughly 8 of those vegetation types occur over peat, okay? And what's also interesting is some of these, like this right here, this right here, these guys occur in localized places where limestone influence is higher, and so pH is higher. So that's it's a whole complex of wetland types. But that's a little overwhelming, right? Okay, you recognize any species on those lists, by the way? Maple. Okay, there you go. Good. Okay. Another way of thinking about it is just general wetland categories. We could be more simplistic. So, for instance, at Cranesville Swamp and a lot of other mountain peatlands, we have open water habitats. Okay, and many of those are created by American beaver, right? Beaver, and It's an interesting thing. There's a lot of debate within the ecology community about the role of beaver past and present in some of these areas. Some people think we didn't have near as many beavers way back then. So do you know that we had beavers and then we didn't, right? Because beavers basically spurred the exploration of the northern half of North America. One gold, it was pelts, right? And we trapped them out and they were gone and their influence was lost. And now we have them again. And the question is there impact? What is their impact on these mountain peatlands? Okay? We have other places that we might refer to as marshes. These are places where you've got standing water, you get plants rooted below the surface of water, extending above. You think about cattails, right? But for most of our mountain peatlands, cattails are not a normal type of vegetation because cattails require higher nutrients than what our peatlands would provide. When we find cattails in our peatlands, we often think something is amiss, that we have higher levels of nutrients that we didn't usually have, either through atmospheric deposition of nitrogen or through influence of agriculture or of septic systems. Okay? And in fact, there are places where we have actively worked to remove cattails from invading some of our mountain peatlands. We have other areas that look like grass. We call them wet meadows or sedge meadows, or locally we call them glades. Okay? Glade is from the same root as glad, and glade refers to an opening in a forest landscape, right? Makes you happy if you've just been in the dark of that forest. But a glade could be dry or could be wet. But locally, when we talk about glades, it's these grass and sedge-dominated wetlands where the soil is wet, but you don't typically have standing water. So you have those guys. You have your classic bog or peatland. Now, we call Cranesville Swamp, but it's really a Cranesville wetland complex. A swamp is a wetland dominated by woody vegetation, and so we have shrub swamps. This would be Finzel Swamp. And we have forested swamps. All these different types of habitats, and they all have interesting plant species. So what I'd like to do is share with you some of the characteristic plants that we find in our mountain peatlands. Now, some are unique to peatlands, some of them you find in other places, but you find them also commonly in our peatlands. And the driver of the whole thing is sphagnum. Now, if you've ever looked at sphagnum up close, it looks like a bunch of mop heads. It looks like Bob Marley and the Wailers, okay? You got all these things with dreadlocks there, okay? And as I told you, we have a lot of different species of sphagnum. Another group of mosses, Polytrichum or haircap moss, this beautiful starburst of moss. There's a cool liverwort. Now there's an oxymoronic term if I've ever heard it, right? Cool and liverwort. But anyhow, if you're weird like me, liverworts are really cool. And there's a genus called Bassania, which is more northern. This is three-lobed Bassania, and each of these leaf-like structures, if you look up close, they have these three little teeth on it. And this is a northern kind of thing, but we have them in our mountain peatlands. Bog club moss, not a moss at all, but a lycopod, and this one actually can grow in water. So the specific epithet for that is inundatum for bog club moss. Ferns, all kinds of ferns, and lots of ferns. Some are specific to wetlands, but they're not very interesting. But you know, cinnamon fern, that beautiful fern that we see coming up in the spring, looks like it was arranged in a vase, very common in these environments. A lot of grass-like plants, and this is very boring to you, and most of my students, it's still boring even if they had to learn them, right? But there are all sorts of things. A lot of members of the sedge family, very characteristic. If you've been out on the boardwalk at Cranesville in the fall, or if you've driven down Rock Lodge by the Block property, you see this in the fall. This is called Tawny cottongrass. Very characteristic bog species. White beakrush, little but really kind of pretty. A whole bunch of look-alike sedges, or look-alike to the normal person. This doesn't even have a name that you usually hear, other than Carex rostrata. But this is a cool thing because it forms these big, clonal, basically single species expanding clumps. Here's an aerial of the glades. See that and that? That's all that same species. It's not aliens, okay, of that one type of sedge. And tussock sedge, this is a classic sedge of wet environments all over the northern hemisphere that forms these hummocks that make walking a bit challenging. And in fact, this and the grass called blue joint are the two dominant species in our glades. If you drive to the end of Mossa Road, right, along Cherry Creek, that's all, mostly those two species. And, you know, grasses are grasses. That's what you think, right? This is beautiful stuff, and it has these subtle changes in colors as you go over the course of the growing season. And you can find this same grass. If Dr. Harrod were here, I would say, when you went by Potter Marsh outside of Anchorage, Alaska, very same thing is what we have here. And manna grasses, these grasses that look like heavily laden with their fruit. Grasses are cool. This is called rattlesnake manna grass. Okay, one of my favorite hair bands of the 80s, by the way. You have, here's a really cool exotic looking thing. This is wild calla. We have, I think, one or two places. You could see this as you go across Finzel Swamp, right? It's related to Jack in the pulpit. I don't know what that's supposed to mean. Or skunk cabbage. In fact, skunk cabbage is common. But skunk cabbage tends to occur where there's slightly higher pH, by the way, okay? And if you want to find bears in the spring, right, you go find skunk cabbage, right? Because think about this. If you're a bear and you've been in your, not hibernation, but winter sleep all winter, you haven't eaten or drank, you haven't had anything to drink, and you have, let's just be honest here, you haven't urinated or defecated for a very long time. And you've developed a little thing that we call fecal plug. Okay, this is biology. Okay, if you want to get rid of that, what do you think you would want to eat? Skunk cabbage, right? Because as my retired colleague Jim Allen used to say, it apparently tastes like rusty razor blades. So anyhow, it does the trick. You know, forget that Metamucil, skunk cabbage next time. In these slightly higher pH areas, you get this really cool little plant. Doesn't look like much unless you're interested in this stuff. Golden saxifrage. And then this beauty right here, which is Appalachian or bog Jacob's ladder, which is really rare. And you can find that I know of in 3 locations in Garrett County. Okay? You know, goldenrods are goldenrods, right? There are lots of different kinds. But there is a specific kind in our bogs called bog goldenrod. And also at the same time of year that you see those, you see a particular type of gentian called narrow-leaved or bog gentian. And then you have sundews. Now, this is round-leaved sundew, and you see the blade, if you will, of that leaf is more roundish, right? And it's photosynthetic, but you see these little hair-like structures, right? They are equipped at the tip with a drop of what we call, very technically in biology, sticky stuff, and they capture insects, and then slowly that leaf encloses the insect, and the breakdown begins, okay? Tom Petty would be proud. So those are herbaceous plants, but woody plants as well. Cranberries. We have 2 species of cranberries. Neither is common, but this is the one you're more likely to see, large cranberry. But in some selected locations, you can find small cranberry, which is state endangered in Maryland. And even rarer still is creeping snowberry, which is really cool stuff. Blueberries of various types, including this one. If you do the trail system at Cranesville, you're going to see this called velvet leaf blueberry. If you look at the stems and leaves, really, really fuzzy. Okay? And shrubs. Glade St. John's wort, okay? Later in the summer, expanses of yellow on the edges of our mountain peatlands in the open is full of this stuff. How many of y'all have seen this haze of red fruits late in the fall? This is a holly. It's a native deciduous holly called common Winterberry. And of even less common species is called mountain holly or catberry that you can find. And it's right along the boardwalk at Cranesville. Okay? They're chokeberries, Johnny Be Good, right? And you have purple and black chokeberry. viburnums, including northern arrowwood. In fact, our shrub swamps associated with our mountain peatlands, we think are super important sites for birds to fatten up in preparation for fall migration, because there are a variety of fruit-producing shrubs, right? Okay? Catbirds. There are catbirds everywhere in these environments in late summer and early fall. The problem is the non-native viburnum leaf beetle is just clobbering this stuff right here. And may potentially change ecologically these shrub swamps. Speckled alder, rhododendron, and then there are trees. Red spruce, our native spruce. So this is in Michigan, right? It was white spruce and black spruce. Here in the Appalachians, it's red spruce. Garrett County. Now, you think of red spruce when you go down to West Virginia, right? To Dolly Sods or Blackwater Falls. We have it, and we had it here. Right up the road, there along Rock Lodge. Lots of red, there still is, but there was a lot of it. And it wasn't just in wetlands. On the east face of Backbone, as you go south towards West Virginia, our region, the Central Appalachians, it's estimated that we only have 10% of the original coverage of red spruce. That was the impact of just wholesale, not managed forestry, just wholesale clearing that occurred around the turn of the previous century. And that's dramatically altered things, right? Eastern hemlock, right? Eastern white pine. And then there's this cool thing, which is Eastern American larch or tamarack. And when you look at this up close, it's a conifer, there are cones, but you see that you have whole clumps of needles growing out of these little stubs along the branch. When you drive past Cranesville Swamp, you'll see these things with very narrow crowns, and that's the tamarack. But this is something weird is going on with tamarack, okay? Because as you go from summer to fall, that foliage turns yellow, or as Aldo Leopold said, smoky gold. And then something horrible happens. It falls off. And you drive around Cranesville Swamp, you go, them pine trees is dead. And then next spring, it's a miracle. Out comes a new flush of needles. So tamarack is this really interesting thing because it's a deciduous conifer. It's an evergreen that ain't. And Cranesville Swamp is the furthest south place in all of North America where tamarack grows natively. It also grows at Finzel Swamp, and it used to grow in the Thayerville Bog. And do you know where the Thayerville Bog is? It's at the bottom of Deep Creek Lake between the State Park and Arrowhead. So that was another peatland at one time. That's one of the things that makes Cranesville Swamp such a cool thing. Okay, red maple, but red maple grows everywhere. Black gum, one of my favorites, beautiful foliage. Yellow birch. Black ash, where you have higher pH. This isn't very common, and of course, just like with white ash, this is getting killed by the emerald ash borer. And one of my favorites, American mountain ash. But it's not just the plants of mountain peatlands that are unique and special, because the vegetation and the physical conditions of these sites create important habitat for a whole host of interesting animals, fascinating, spectacular animals like snails. So there are some rare snails that are associated with these environments. This is the spruce knob three-tooth. Let's all say that together. Spruce knob three-tooth. Beautiful, okay? And this, the striped white lip. They're beautiful, right? Okay, you just got to look at them, okay? My friend and colleague with the Maryland Department of Natural Resources Wildlife and Heritage Program, biologist Dan Feller, says this. He says, peatlands are biodiversity hotspots for odonates. Those are dragonflies and damselflies, okay? And our mountain peatlands host a number of northern or boreal species that are far south of the main part of their range, okay? For instance, this is right here, that's the Canada darner, which Dan says is the quintessential odonate of North American peatlands. And they're all the way down here, south of the Mason-Dixon line. Hudsonian whiteface, another one. And, you know, so many cool things. This little tiny guy, this is a bog copper. And bog coppers host on cranberries. And so because cranberries are rare, so are these in Maryland. They're state endangered. Now, we've seen a lot of yellow butterflies, but this is a particular kind called the pink-edged sulfur, which hosts primarily on velvet leaf blueberry that I told you about. Okay? And then there are, avert your eyes, there are a couple snakes. This is the mountain earth snake, which is made distinctive by its complete lack of distinctiveness. Okay? Very, very plain. It's not a very big snake, and they are hard to find. They're state endangered, and they tend to be found on the edge of these peatlands. I took out a group for the Maryland Native Plant Society a couple years ago, lifted a rock along North Cherry Creek Bog, and there were two. So they're there, but they're rare. And I find that our peatlands, this isn't a rare species, but our peatlands are good places to find smooth green snakes, which are just lovely little guys. And they're mammals. For instance, the southern water shrew. Now, water shrews are pretty cool because they will actually dive below the surface of the water. And they can run across the surface of the water. Okay? And if you haven't had wildlife biology, guys, you're going to hear me tell a story about southern water shrews that we won't repeat. Okay? But anyhow, most of the records for these here, this is rare, very rare, are found in our bogs or in the streams that feed into our bogs. And then, of course, there are birds. Okay? For instance, one of the standard sounds of the shrub swamps that are mountain peatlands is made by this. This is a swamp sparrow. There are lots of kinds of sparrows out there, and they're lovely, subtly beautiful. And these guys do this kind of slow trill. They go dip, 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 dip. And that's the swamp sparrow. This very plain looking flycatcher belongs to a group of very similar looking birds. The genus is Impidinax, and they drive people crazy. But this is found in our mountain peatlands. It's called an Alder Fly Catcher, and it sings a song about something that I would really have liked to hear more about when I was in college. They say, free beer, free beer. And we find them here. We're in Garrett County. Our mountain peatlands is a hot spot for them. Similarly, this plain-looking bird is a northern water thrush. And they nest in shrub swamps and forested swamps. And I was just lucky enough one time to find a nest, one flush. So in these wetlands, because you've got saturated soil, trees have very shallow root systems, but widespread. They're more prone to wind throw. And there was a tree that had been upended, so this big root system on its side, and out came a water thrush from the bottom of that root wad. And as I looked back in there, tucked in there was a nest. They have not a very exciting song, but they go tip, 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 tip. Let's all do that together, or not. Okay. And this lovely little thing, this is a Nashville Warbler. And they are very, in our area, very specific to these open areas of peatlands with some trees on the edge. And not a very exciting song, but these are really, really rare. But we find them, for instance, at the glades. Okay? And then my buddy, the northern saw-whet owl. The very first record of a nesting northern saw-whet owl found in Maryland was found by our students at Cranesville Swamp. In fact, most of those records have come from our peatlands because they are birds of conifers, right? And so there you have it. So I hope that I've impressed upon you just how special, how cool our mountain peatlands are. The conditions that are found in these sites they're unique and they're fascinating. and these sites are full of rare and distinctive species. But these sites are far more than simply a collection of interesting species. They're more than the sum of their parts. For me, what really makes them special and makes them cool is how they feel. How I feel when I wander through them. How they sound. How they smell. How seemingly chaotic but beautiful that they are. They are rich and beautiful and rare and special places. You walk into a spruce and hemlock shaded swamp forest on a late spring evening, and the subtle smell of rotting eggs as you slog through comes to your nose, and I love that smell. And I had COVID like over a year ago, and things don't smell the same still, and if I lose that smell, I love the smell of skunk cabbage. I'm serious. And if I lose that, it's going to kill me, because that's a great smell. And so as you walk through, as the start of twilight, you hear the veeries. And you hear the hermit thrushes. You hear their songs swirl and twirl their notes around you. Or you step down into the edge of the shrub swamp at dusk on a soft April evening, and the sun is setting, and the peeper chorus is swelling, and a big, gorgeous full moon is rising up in the east. And as it gets darker, and the temperature begins to drop into the upper 40s, and a light fog begins to settle over the heart of the peatland. And the peepers begin to quiet down, and then you hear it out there in an island of spruce and hemlock and rhododendron. It sounds like a bell. It's not an impressive sound, but it's an evocative sound because it's the call of a northern saw-whet owl. And it's a sound that you would have heard far more frequently 125, 150 years ago, before the old-growth spruce and hemlock and white pine was felled. It is a sound that connects you back with the heart of the peatland and with the heart and the legacy of our region. That's what makes mountain peatlands so special. So I think mountain peatlands are cool, and I think that you should too. Thank you.